Part D.4, Power and Energy Consumption. For the remaining 2 videos of this part, Part D, I want to talk about this topic. In computer system design, this is another important consideration. All right, so let's start with the first topic, CPU power consumption. How much power consumed by CPU? So we just get some, initial idea on it. Some facts in power usage. First, for a given device operating at a high clock rate. So here, let me first explain this clock rate a little bit. So what is the clock rate? CPU clock rate. CPU clock rate. Inside CPU, there is a clock, a special clock. So not our regular clock, CPU clock, running very fast. So the clock rate usually at gigahertz. So when you buy a computer, you have that measure 2.5 gigahertz, 3.6 gigahertz. You have that kind of number, right? That's the clock rate. So running very, very fast. So this is a basic and important concept. So later, when we calculate the performance of CPU, so we need to use this concept a lot. Here, you just get idea. When the clock rate is high, then the CPU running faster. That is related. So here, for a given device, so what kind of device? The device inside CPU, or a device controlled by CPU. Many devices controlled by CPU. How to control? Based on the clock cycles. Another concept, clock cycle. Clock cycle. Clock running at tick, right? Tick, 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 So one clock tick corresponds to one clock cycle. One clock cycle, So those devices we're talking about here, controlled by the clock cycles. So later, when we study instruction set, CPU instruction set, so we will use, clock cycles a lot. Everything we're doing based on the clock cycles. All right. Operating at a higher clock rate may require more power. So that's pretty natural. So because you want to run faster, you want to do more work, right? You need to consume more power. So that's pretty natural. All right. New features generally require more transistors, each of which uses power. Think about you build more and more transistors on the chip, right? But at the same time, when you increase the number of transistors, you also reduce the transistor size, right? So when you reduce the transistor size, you can reduce power consumption, right? Increasing number of transistors, you will increase the power consumption, but reduce the size, at the same time decrease power consumption. So here, let me use some pictures so we get a rough idea how much power consumed by typical CPU. Power consumption here. Here you can see these CPUs, relatively old CPU, yeah. Pentium D, yeah. So AMD, 10 something years ago. Yeah. So that's the, pretty old CPU. So you can see for each CPU, there are two numbers on power consumption. The red bar, longer, that corresponds to loaded. Loaded, that means the CPU is running, doing some processing work. Loaded, working, yeah, at the working state. Yeah. The blue one, the blue bar, idle. The CPU does not to do any computation work. Idling, yeah, idle, yeah. At the idle state, CPU still consumes power. Yeah. So you can see, although the red bar is longer than the blue bar, but you can also see, even for the blue bar, power consumption 154 watts. Yeah, the unit is watt, watts. So you have an idea, kilowatt, right? Our light bulbs, certain number of kilowatts. Here in computer, the CPU, not kilowatts, kilowatt too big, so we use watt. Yeah, we use watt. 154 watt. Yeah, that unit. Yeah. All right. But these numbers for 10 something years ago CPU. Yeah. So for the recent new CPU numbers, those numbers reduced a lot. The technology improved, many rounds, and the power consumption number is bring down significantly. Yeah. All right, so we will see another picture later soon. Yeah. So now, as a processor models design matures, smaller transistors, the size smaller, okay, lower voltage structures, the voltage. Yeah. So you apply voltage on transistors, also related to power consumption. The higher the voltage, the more power, right? Yeah. So here you can see lower voltage. So we can do the same computing work with lower voltage. Then we can reduce the power consumption. In other words, our new advanced CPU technology, we can do the same computing work with much less power. So this voltage is important. In my next video, the last video of this part D, we will learn formula, power consumption formula. In that one, you will see the voltage plays big role there. Yeah. All right. Okay. And the design experience may reduce energy consumption. Yeah. So you can see there are many different ways we can improve power consumption. Yeah. Some factors increase power a little bit, but there are many other technology improvements to reduce power consumption. So the overall, we can make the CPU power consumption reduced significantly. Yeah. All right. Yeah. So in many applications, the CPU and other components are idle much of the times. So here, yeah, much of the time. Yeah, so in this picture, so why we look at the idle state power consumption, right? Why we look at that? Because usually we want to look at the power consumption when CPU is working, right? So that's the number we are interested. The reason is simple. The reason is CPU, other components are idle much of the time. Although you turn on your computer, right? So you do some work, yeah, but in a big portion of the time, it's in the idle state. The CPU is in idle state. Yeah. So for that reason, so when you try to measure the overall power consumption, the idle state is very important. Yeah. All right. So idle power contributes significantly to overall system power usage. Yeah. Yeah. All right. This is a picture, power idle watt. Yeah. So here you can see, comparing with the first picture, so you can see, yeah, these CPUs, much newer, yeah, more recent CPUs. Yeah. So you can see the power consumption. We just compare the idle state power consumption. You can see greatly reduced. How much reduced? Here, let's just compare the Intel CPU. Yeah. The first one here and the first one here, Intel, right? The first one there, 150 in that category, 150, that big idle power consumption. And here, also idle, you can see 25, much smaller. Yeah. Even, so you can see even the largest one, just a little more than 100. Yeah. Yeah. Still, the difference is pretty big, you see, from 25 to 100. The difference is pretty big. Yeah. Yeah. Because the CPUs could be used for, different machines, right? Laptop, so you may not use very, very powerful CPUs, right? For servers, so servers you like to use, much more powerful CPUs, right? So for that kind of thing, still the difference is pretty big. Yeah. All right. So here you just have some rough idea related to the CPU power consumption. Yeah. Next, let's look at the power consumption in data center. So mainly, we want to look at a server power consumption, server machine. Yeah. In data center, large number of servers used in a data center. How much power consumed? How much energy consumed? Yeah. So here, the power related to energy, right? The power is a factor, but when you build up through a period of time, you look at the energy. Yeah. The power you measured, instant state, energy used in a specific period of time. Yeah. But now suppose you have 1 year period, because when we look at a data center, we want to look at a 1 year period. How much is the electricity bill? That number is important for those big companies running these data centers. So let's look at that part. So this is a picture of a typical data center. Large number of servers. So running all the time there. 24/7, right? So 24/7 and the whole year. Yeah. Sometimes some servers may, go down. Yeah. So replaced by new servers. Yeah. So that's okay. But for all the servers together, so you can see we can consider they are running the whole year. Yeah. All right. So let's do some simple calculation. Yeah. The electricity bill for a reasonable size data center each year. How much? What is the dollar amount for a typical or average data center? Yeah. So let's look at the number. We use, so one server, here I searched the web. There are many different numbers, but here I choose an appropriate number, 400 watts per hour for one server. Yeah. Yeah. Some server consume less, some more, so I just pick, somewhere appropriate. 400 watts, the number. Okay. Next, all right, consume the electricity rate at $0.2 per kilowatt hour flat rate. Yeah. So that number, I also choose some number reasonable, yeah, because on web I got 10 cents something, 10 something cents. Yeah. Different locations, that rate different. So here I just select, average, reasonable for the whole country, yeah, $0.2 kilowatt per kilowatt hour. Yeah, that rate. Yeah. Then we know in 1 year there are 8,766 hours in 1 year. So we just do multiplication. So we can estimate the dollar amount for this server. Now, so what's that? Oh, so yeah, this number should be 2. Yeah. Yeah. This number should be 2. Yeah. All right. If it's 2, right, $700. If I use 2, okay, yeah, because 0.1, that's the cheapest dollar amount. The rate, cheapest rate. 0.1 is the cheapest rate. 0.2, not the highest, but somewhere middle, above average a little bit. Yeah. And we need to consider location, different places in the country. Yeah. All right. So here, yeah. So let me use this. Yeah. Because the formula I got from web is uses 0.1. So that's why in my calculation here, 0.1, but in the number I use here should be 0.2. Yeah. $700 a year for one server. $700 for one server. Okay. All right. Then how many servers in a data center? Yeah. This is a reasonable number. 60,000 servers in a typical data center. Some smaller, some bigger. So I just pick somewhere in the middle, 60,000 servers. Now you do multiplication. Yeah. Actually, we need to multiply by 2. multiply by 2, so you get a number. Yeah. 42 million. Look at this. 42 millions for that data center. So when you make a plan for your business, look at that number spent on the electricity bill each year, $42 million. How big is that? $42 million. Just for the electricity bill. Is that pretty big? So you can imagine that. Yeah. Here, so that's why I want to give you some, concept in your mind. How big is that number for a typical data center? Electricity bill. Yeah. All right. Next, we want to look at a cell phone power consumption. Yeah. So the small device, yeah, consume pretty small amount of power energy, right? Yeah. How much? Yeah, we want to also see that number. Yeah. Here, so let's look at the electricity cost of a cell phone. Yeah. Estimate roughly electricity cost. Yeah. Yeah. Some company did that research a little bit. So I just got the numbers from articles. Yeah, here. All right. If you just do one charge per day, depends how many charges you do per day. If you do one charge per day, you get $1 per year. That small, that little. The electricity cost to power your cell phone for one whole year, only $1. Is that surprising? It's surprising to me. Yeah, surprising to me. Why so small? Well, but usually people do, 2 charges or 3 charges, right? Yeah. So usually people do 2 charges or 3 charges per day. You just spend $2 per year or $3 per year. That's still a small amount, right? The whole year, you just pay $2 or $3 on your electricity consumed for your cell phone. Very surprising. Very, very surprising. Yeah. But anyway, so that's the number I got from, several articles. Similar numbers like that. Yeah. All right. So let's stop here. Video D.4. The next one, we will learn some formulas, and then we can use those formulas to solve some questions. Yeah. All right, so let's stop here first.